H2O, good old H2O. H2O, H2O, H2O. What does every one of these represent? Represents the smallest particle of water. In other words, one water what? One water molecule. And this is called a ball and stick model. Now this is a larger ball and stick model, and for obvious reasons. We've got balls and we've got sticks, and everything about a ball and stick model represents something. For example, I've written it here with letters, which represent the same thing as these red and white balls. What does each letter represent? Well, you might say the O represents oxygen, and you'd be partly right, except in a ball and stick model, it specifically represents one oxygen what? One oxygen atom. One oxygen atom. And the same for this H right here. That represents hydrogen, but in a ball and stick model, one hydrogen what? One hydrogen atom. Now, one thing we haven't talked about too much are these sticks. And so this is a ball and stick model, and so there are sticks, so to speak. What do they represent? Well, they represent a force that is holding the atoms together. It's called a chemical bond. A chemical bond. And if you take chemistry, you'll learn a whole lot about chemical bonds. We're not. But we do need to know a couple things. One, what forms chemical bonds? Well, a very tiny particle, a subatomic particle, called an electron. So chemical bonds involve electrons, and the only thing we need to know about electrons, besides the fact that they're extremely small, is they have a charge. They're either positive or negative. Which one is it? Yes, they are negative. You are absolutely correct. They are negative. That's a minus sign that indicates a negative charge. So everything about the ball and stick model, the entire model represents what? A molecule. So let's review what we've learned using this model of a little chunk of glucose, the smallest chunk of glucose. And so again, each ball represents one what? Each ball represents one atom, right? What's an atom again? The smallest particle of an element. So atoms, the sticks represent chemical bonds. We just talked about that. And the different colors, what do they represent? Well, they represent different somethings, different whats that we talked about. Yeah, different elements. Different elements. So glucose is made of 3 elements. 2 of them we just talked about. They're in water. Hydrogen and oxygen. And what's the third one? What's the black one? Well, the black balls in this model set represent carbon. Carbon what? Carbon atoms. So we've got carbon, hydrogen, and oxygen. We'll learn more about glucose in the next module. All right, and so let's mention one other thing about water. A water molecule, and that is the fact that a water molecule is polar. It is polar. And what does that mean? Well, it means one end is different than the other, but how are they different? Well, let's draw another representation of a water molecule, and we know what the different parts represent. These chemical bonds are formed by electrons that have a what charge? A negative charge, and the electrons are thought to be kind of zipping around in there. But it so happens that oxygen has a much stronger pull, a much greater electronegativity, a much stronger pull on electrons than hydrogen atoms. So these electrons are moving around here, but they're pulled much more of the time, much more of the time. The electrons are pulled much more of the time, or spend more time, you might say, at the oxygen end. So the negative electrons spend more time toward the oxygen end. That makes the oxygen end slightly more negative compared to the hydrogen end, which would be slightly more positive. And so that's your polar molecule. A negative end, the oxygen end, a positive end, the hydrogen end. Now, what effect does that have? Lots. For one thing, water molecules cling together. I bet you didn't know that. Well, we take it for granted, but it's incredibly important, incredibly significant for life on Earth. And so let's illustrate that. Ooh, I changed colors. Oh well, that's all right. And so let's represent the polarity of each of these. And so why would water molecules cling together or be attracted to each other? Well, negative is attracted to positive, right? Opposites attract. And so I'll put a little dotted line indicating that it's what compared to a chemical bond. Not near as strong as a chemical bond, but it is a significant force in nature. It has a name. There's more to it than this, what I'm putting up here, but we will say for our course that a hydrogen bond is the attraction between water molecules, and it has a significant effect on life on Earth. Here's some water. It sloshes, and it's liquid H2O. We take that for granted, and but that actually is pretty unusual compared to a lot of things. And why is it? Because of these hydrogen bonds. In order for water to change H2O to change to the gaseous state, what do you have to do to it? Well, to get it to happen very fast, you got to put a fire under it or something, right? You need to boil it. And why does boiling take energy? What are you doing when you boil water? You are breaking those hydrogen bonds that hold the molecules together. It takes energy to do that. It takes, on Fahrenheit scale, 212 degrees Fahrenheit to break those bonds. And so as a result of these hydrogen bonds holding the molecules together in the state that we call water, H2O is a liquid at the temperatures we normally operate in. Is that important for life on Earth, if water be a liquid? Yes, it is. And so, again, what causes that to be something we take just totally, utterly for granted? It's the polarity of the water molecules and the resulting hydrogen bond between water molecules. All right, thank you. Let's return to the lesson material.